Alright guys, we are heading to the home stretch of our unit. We are going to cover how to find volumes of three-dimensional figures. I'm going to gradually release you guys in terms of the amount of figures that you guys are responsible for, but we're going to start off pretty easy. So for the very first shape that we're going to cover is basically anything that is the shape of a box. So if you look at problems number 1, 2, 3, it's like a box that you would receive from either Amazon, Christmas, birthday present, etc., right? Finding the volume is super quick. You take the length, the width, times the height, and multiply it. So for the very first one, volume is equal to length, width, height multiplied together. So that's going to be 9 times 17 times 24. And if you do that correctly, that's going to get you 3,672. And since we're talking about volume this time, it'll be centimeters cubed. As quick as that. All right, so any box shape, length, width, height, just multiply it. All right, now not everything's going to be nice box. Now we have other types of boxes. So the very first one we have on problems 4, 5, and 6, number 4, that is a triangular prism, not a pyramid, which the two often get confused. A pyramid is kind of like, well, it all converges at one point, right? So, you know, like what you see in those like history books or whatever geography books, it all converges at one point. The thing with a triangular prism, like number 4, is that you want to go ahead and understand it's kind of like a wedge of cheese or maybe like a door stopper that you slide underneath the door to prevent it from sliding. That's more of a triangular prism. And it's pretty easy. What you're going to do is, for this one right over here, volume is equal to the area of the base times the height. Well, what's going to be my area of the base? Now, when people think of base, they kind of think, oh, it always has to be the bottom figure. But if you're talking about a triangular prism, which I'm naming it on purpose, it's actually going to be the two sides that are congruent to each other and parallel to each other. If you look at it, it's kind of like staggering, one in the front, one in the back, right? That is a triangular prism. What we need to do is we need to find the area of the base. Our base is a triangle, right? Our base is a triangle, and the formula is 1/2 the base times the height. Now, if you remember what I talked about before, the base and height are the two sides that form right angles. Well, what's forming a right angle in here? Well, I have over here that side and that side. So when I do it, I got 1/2, right? And the base is going to be 12 times 7.3. Now, doing that, put that to your calculator. If you do that correctly, you should get 43.8. 43.8. Right? That's only part 1, right? Now we got to find the height. Now, the height, you're always thinking, well, I'm standing up. That's going to be my height. Now, the height is actually the distance between the two sides that are parallel to each other. So when you're looking at prisms, you need to find out what two sides are the exact same shape, but they're running in the exact same direction, which happens to be the triangle. So the volume is the area of the base times the height. Well, we know that the area of the base is going to be 43.8, and the distance between the front triangle and the back triangle is 5. When you multiply that together, that's going to get you 219 cubic feet, right? Number 4 and number 5 are exactly the same. I'm going to do another problem with you guys. These are tricky, all right? Again, we're going to spend 2 days on the same lesson. Looking at number 6, this is a trapezoidal prism. How do we know? Well, the trapezoid right over here, I'm going to shade that right there. This trapezoid is the same as this trapezoid, and they're running parallel to each other. So that's going to be our base. We just need to find the area of the base. So the area of the base is a trapezoid, right? That's going to be 1/2, right? And it kind of looks distorted. Hopefully you guys actually have another PDF file on hand to look at this clearly. But the height forms a right angle with the top and bottom base. Well, the height is going to be 17.9. And base 1 and base 2 are the two sides that are parallel, which happens to be 36 plus 14. Right? If you put that into your calculator, that's going to net you 447.5. Now, last part is we need to find out, okay, what's the distance between the front and back base, right? What are the two sides that are parallel? What's the distance between the two parallel sides? It happens to be that it's going to go ahead and be this side, right? These are parallel running across here. What's the distance of it? Well, it's 25. So volume is equal to the area of the base times height. So that's going to be 447.5. And then the distance between the two bases of the three-dimensional figure, not the two-dimensional figure, the distance between the big bases is going to be 25. And then if you put that into your calculator, you get a big giant number, 11,187.5 cubic meters. Right? So a little bit tricky stuff. 7 and 8 are exactly the same. So let's scrolling through this. 7 and 8 are exactly the same. So if you need guidance, number 4 can be used for number 5 and number 7. And number 6 can be used for problems like number 8. So good reference. Believe it or not, the last type of prism is pretty easy, right? It's a cylinder, so like a can of soup, right? Can of soup, or like a nicely rounded shaped cake. So a cylinder is volume equals to pi r squared times the height. The radius is always going to be the distance from the center of the circle to the side of the circle. So when I put that in, pi would be 18 squared times 15. And then if you put that into your calculator, you can put that, you can use 3.14 or pi. I'm going to give you guys options that you can pick either answer. If you're close, you'll get the full credit. If you do this correctly, the answer to this is going to be 15,268.14 cubic inches. Alright, cool. Let's do one last type of word problem. Alright, word problems, they're a little bit tricky, but if you try to go ahead and tackle one bit of information at a time, you'll be fine. So let's do number 11. It says a cylinder with a 2 centimeter diameter is drilled through a triangular prism. So we have a triangular prism, and there's a drill that's going straight down. Right? Find the volume of the prism. So we need to remove that hole when we're calculating our volume. So it's like what we did yesterday. So we need to find first the volume of the triangular prism, and then we're going to find the volume of the cylinder, and we're going to subtract it. Well, let's do this, right? So for figure number 1, the volume of any triangular prism is area of the base times the height, right? We do know the base, since it's a triangle, it's 1/2 base and height, the two sides that create the right angle. You might not see it. It's a little bit tricky to see it, but there is a right angle over here. So area of the base is going to be 1/2 5 times 5, all right? And if you do that correctly, that's going to net you 12.5. So what are we going to do with this number? Well, we're going to put it back into the volume formula. So that's going to be 12.5. And the height of the three-dimensional figure, well, since the two triangles are congruent and the same and they're parallel to each other, the height is going to be the distance between the two of them. So that's going to be 14. If you do this correctly, this should net you 175. Okay, that's only the triangular prism. But remember, we're removing a cylinder directly from the middle of the triangular prism. So the very first part we're going to do to find the cylinder is we know that the volume is going to be pi r squared times the height. And they said the radius is needed for the formula, but they give you a diameter of 2. So if my diameter is 2, to find my radius, I take that number divided by 2, so 2 divided by 2, the diameter is 2, divided by 2, my radius is going to be 1, so that's going to be pi times 1 squared times, well, what's the height? Well, the height of the rectangular prism was 14, therefore that cylinder that's drilled directly in the middle is also going to be 14. So, putting this into the calculator, you have an answer that's going to be approximately around 43.98. Right? So I have my triangular prism, and then I have my cylinder, and I'm going to take my volume of the two and subtract it. So 175 minus 43.98, sorry for the gap. If we do that correctly, the volume of the triangular prism with the hole cut out is around 131.02 cubic, not squared, cubic centimeters. All right, guys. I know this is a little bit tricky. If you're having trouble, remember we do have a Google Meet on Friday right before the quiz, so I'll be here to answer any of the questions, right? All right, take care, guys. Stay safe.